Okay, we are doing square roots. Now, I want you to take a look on your yellow sheet. Look at the top. Notice it says quadratic parent function x squared. You see in the very top left corner. Now, that's what we're going to graph in this left grid. So I want you to just put a few points. 0, 0, 1, 1, whoops, 2, 4. And remember, this thing reflects over the y-axis. Let's see, 3, 9. Can you do 3, 9 or no? Oh, well, okay. Okay. Just put what you can. You know that this is y equals x squared. Now, if you'll notice on the upper right corner, it says blank function and then a colon. Do you see that? In the upper right corner of your yellow paper, you need to write this in the first blank. It says square root function. And then after the colon, write that. Now, you have some room. Actually, you have a little table here, right? I want you to put these points. When x is 0, y is 0. When x is 1, y is 1. When x is 2, y is 4. Now, I know you couldn't fit this one. When x is 3, y is 9. But go ahead and write it down. Now, for square root, remember a little bit ago we just kind of drew a square root. What is the square root of 0? 0. What's the square root of 1? 1. What's the square root of 4? 2. And the square root of 9 was 3. We said the square root of 0 was 0, the square root of 1 was 1, the square root of 4 was 2, and the square root of 9 was 3. Again, this is not on your yellow sheet. So just put your pencil down and just think with me. And if you don't understand what I'm saying to you, don't stress about it. You'll notice x squared is a parabola. You'll notice the square root of x is on its side, and it's like half a parabola. You're probably wondering where the bottom half is. Ladies and gentlemen, do you remember what it means for a graph to be a function? If a graph is a function, we know it passes something. For a graph to represent a function, the graph has to pass the vertical line test. You guys knew that. If we had the bottom, that would not pass the vertical line test. Remember the vertical line test. Okay, I heard somebody say I can't even see that, or that's too bright. So let me just do it in another color real quick. Whoops, dadgummit. Let's see if I can erase that a little. There. That was not the intent, I promise. Let's see if I can try that one more time. Well, how about we just redo this part and make me quit looking like a fool? Okay. Now, that's terrible. 1, 1, 4, -2, 9, -3. That's a little better. Now, if I pass a vertical line right here, that's right. That graph fails the vertical line test. But what does that mean? It means the x value of 4 is paired with what y values? 2 and negative 2. It means one x value is paired to two y values. That's a no-no. You can't have it. Right here, this x value of 2, the square root of 4, is 2. But this says the square root of 4 is also negative 2. Remember when we take a square root, we do plus or minus? Problem is that that whole parabola on its side doesn't make a function. So what we have to do, let me draw this again, 4, 2, 9, 3. What we have to do is we have to go over here to the parent function, and we have to do something called restrict its domain. Now, this is the piece that is not part of Algebra 2. It's not part of any Algebra 2. It's part of pre-cal. But I'm going to teach it to you anyway because you guys can understand it. Yeah, just stop. You can understand it. If I didn't think you could understand it, I wouldn't teach it to you. This graph, if the bottom part was on here, would fail the vertical line test, correct? This graph fails a horizontal line test. If I draw, and I'm going to draw it in green, this graph fails a horizontal line test. Do you see that it fails a horizontal line test? Because this fails a horizontal line test, its inverse, which is really the whole parabola laying on its side, is not going to be a function. So what we have to do is we have to restrict this parent graph where it would pass not only the vertical line test to be a function, but a horizontal line test. So here's what I'm going to do. I'm going to say bye-bye. Now let's take a look at the piece that I've left. The piece that I have left passes a horizontal line test, doesn't it? Which means this one is going to pass the vertical line test. If this one, the red one, passes a horizontal line test, then when you flip it over, it's going to pass a vertical line test. Ladies and gentlemen, what you just learned is called a one-to-one function. Yep. Let's go back. I want you to notice, look what happened. Do you notice that the x and y's just switched? When the x's and y's just switch, what you have are two functions that are called inverses. And that's what you see on that line. Do you see that line between the two graphs, that dotted line? Huh? You already knew that? Excellent. Excellent. Now here's the deal. When you have a function and you switch the x's and y's, then you have its inverse function. What? Okay. Now, let's look. You have on yours right below the left graph, it says domain, and then it says restricted domain. You see that? Okay, where it says domain, it means the domain of the entire x squared function. Now, I want you to look at that. What is the domain of the entire x squared function? What x's can I square? I can square any x, can't I? So, the domain of x squared is all real numbers. Now, do you remember how we write that? How? Okay. Yeah. Okay. X such that x is an element of the real numbers. And then below that, it says restricted domain. The restricted domain was to make this graph pass a horizontal line test. So notice I cut off all the x's that were negative. I don't have them anymore. So what is the domain of that red graph right here? It's all x such that x is what? Or 0. Yep. It's all x such that x is greater than or equal to 0. And let's talk about the range. The range is the y. Now, if I put this back up, remember a parabola, oh my gosh, does that parabola have a minimum or a maximum? Has a minimum. So are all the y's above that minimum or below that minimum? Above. So the range is all y such that y is greater than or equal to what? 0. There you go. There you go. Under the other graph, it says domain and range. Now, I want you to think about this. And I erased it up here. But for a function and its inverse, what do we know about the x's and y's? What do? They switch. But x is domain, y is range. So if they switch, the x's are going to be the range and the y's are going to be the domain. So let me show you what I'm talking about. Now you've got all this, right? The domain of the inverse is going to be the range of the original. What was the range of the original? Y is greater than or equal to 0. So that's going to be my new domain, but it's going to be x now. They just switch. That's what happens. The range. The range of the new one is the domain of the old one, but it's the restricted domain. All y such that greater than or equal to 0. Please take a look at this graph right here. Do you see that the x's are all greater than or equal to 0? And do you see that the y's are all greater than or equal to 0? That whole graph is in the first quadrant with the exception of the origin. Okay. Look down here where it says example 1. We're right below the graphs. Identify the transformations of each of the following functions from the parent graph of square root of x. Let's look at that first one. Yes, ma'am. No catch. No catch. Now, the original, the parent function is this. What gets done to it? What's that 2 do? Vertical stretch by a factor of 2, and what does this left 1? That's it. So you're going to write down vertical stretch by a factor of 2 and left 1. That's it. When you do a vertical stretch, what do you do to the points? Multiply what by 2? Y value. Good. Let's go to the B one. G of x equals the square root of 2x and then a plus 1. Okay, horizontal. This sucker does something horizontal. It's exactly the same thing you've been doing. You're just doing it with square root instead of x squared. Horizontal what? Does a horizontal tell the truth or does a horizontal lie? Horizontal rise, so vertical, or excuse me, horizontal shrink. By a factor of 1/2. And then you're right, Shaylee. Then up 1. Shaylee. If you do a horizontal, do you mess with the x's or the y's? The x's. If you do a horizontal shrink by a factor of 1/2, what do you do with the x's? Multiply by what? Multiply by 1/2, which is the same as dividing by 2. Parentheses around the what? I don't have an x squared. You mean like this? If you need to, that's fine. Yeah, no problem. Honey, it's all right. Hey, tomorrow's this time tomorrow we're going to be right? Okay. G of x. Can we, yeah, there you go. Here we go. C. What have we got? Reflect over x and up 3. Questions? No. Can I go back to that? Yep. I think I forgot to record F. F is a vertical shrink by a factor of 2/3 and a reflection over the y-axis.